Okay, I'm going to go ahead and record this just simply because I'm going to be dropping some hints on how to finish up this lab here. You may want to refer that. Okay, this is the assignment from last week right there, which I'm assuming that you're still working on that there. Let me just drop a couple of hints on finishing that real quick. First off, as we look at this right here, this is where all the work needs to be done right there. So what you simply, as we look at this code here, this is Blinky. You might want to you might as well just use this code as your starting point right there. Change this to whatever you want to call it. Rename the file and use this as your starting point right there. Now remember we said that these shorting blocks are not on ours, so we can ignore all this right here. That there, all that can be ignored right there. The only thing is ours is DS1. Is it DS1? As I recall, looking here at my desktop. That's not the one. I can never find the. Yeah, this is the. Right. Because these are our two boards. DS1 and DS2 are the LEDs right there on our board right there. So, okay, going back to our code here. Again, I pointed out that don't change some key things here. I'm going to go ahead and make some changes to this code to kind of highlight where you're at. For last week's lab, you have to add a second. You have to add a second one. It's right there, and this is DS1. I'm just pointing out the changes that, in order for this to be accurate, DS1, plot 1, right there. This is DS2, and this is port 1, right there, right there. So that changes. And you need to change that to bit 1. So what this does is this adds on that second LED that we need for the second part right there to test to see if this is working. We're going to be doing another function here, right here. So we're going to have another function. So we need to add another function prototype right there. We haven't wrote the function, but we're going to be adding another function, and it's going to be start timer, right? And it's going to receive int and nsec if you follow the instructions right there. So I would just go ahead and put the prototype up there now, because as you remember in C, we have to put all of our function prototypes at the top, right there. So now, getting back to this here, main, for right now, main is just doing two things, right there, or three things. You're going to leave that the same. We're disabling the watchdog timer for now. Later on, as we get into the next couple of weeks before we finish this project, we'll stick the watchdog timer in there. Yeah, we had a long discussion yesterday among the faculty about students arriving late and locking doors. That may become a procedure within ICLO. So those of you that are arriving at 8:40 for an 8 o'clock class, that's pushing it. Out there. I normally wait till about 8:30 to start, but get much beyond 8:30 then. And the problem is sometimes if I started this class, my lecture on time, those who are walking in will completely miss it, because I'm only going to be talking about 15-20 minutes today, and the rest of the time is working up there. Okay, so this part here, you're going to leave alone. You don't change any of this for right now, right there, because all this is set up. I've decided with this class right now, we're not going to do anything with changing things. Now, our port initialization for right now, we're going to be, for this lab here, we're only using those two ports. However, if you read the original lab, this only set up, the original code, it only used 1 bit. We're using 2 bits, so we need to change this to a 3, because if you look at port 1 mode out, you set a 1 on any bit that you want it to be push-pull. Now we're going to be using 2 LEDs, so we have to set both bit 0 and bit 1 to push pull. That's why I changed that to a 3. This right here, and what have we got going here? Oh, here we go. Right there. Open OneNote. Right there. If you look at port mode, port 1 mode, I can't remember the rest of the right there, the port number, yeah, port MD out, right there. If you look at port mode MD out, that's a special function register right there, and it's got 8 bits attached to it. Each bit right there, 0, 1, 2, 3, 4, 5, 6, 7. If you put a 1 in there, that makes this a push-pull. So this makes port 1.0 a push-pull. How do I know this? You dig through this nasty document, wherever it is, right here, right there. You dig through this nasty document right here, and you find analog pin definitions, communications, right there, program counter, timer, watchdog, general features, I/O. You go to like page 26 in this document. I'm just going to jump to 26 here. Right there. And 26 is actually right there. Has a following feature: push-pull or open drain output. Set there, analog and digital modes. And by the way, you should know, hint, the difference between push-pull and open drain outputs. What the difference is, and you should know what the circuits look like. I drew those in an earlier class, right there. You should also know the function of the crossbar. This is kind of the overview right there. As you go dig deeper into this, you'll get the special function registers and what they mean. Right there. And again, as you read this long document, it tells you everything there is to know about this chip and how to use it. A true test of your ability to understand this would be to, and you will look here, wherever it's at, it's one of the first ones here, right here, output mode right there, and that's covered on page 192. So this should actually be 192 is where it's going to be right here. Right here. And as you look at 192, this tells you right there how that port's set up right there. This is port 0, but port 1. Right there. But actually it's supposed to be 192 as it's port 0 right there. We can just look at port 0, it doesn't matter. Right there, they're the same. But this tells me that port, either it's 1, 2, or 3, mode, out, and it tells me that they all reset to open drain output. And if we want to use a pin that they're as push-pull, which we would do if we're using it as a, actually we would probably use the push-pull regardless right there. But that's where, without getting too sidetracked, this mode, that special function register, if we want a pin to be used as an output, and remember we're driving an LED with it. So if we're driving an LED, push-pull means the output is going to look something like this, VCC right here. Here's my, I'm showing it as a transistor. You know, it's actually a JFET, but it's going to look like this right here. And this is my output. So in other words, when I put it high here, I have a voltage here that I can drive an LED right there. So if it's open drain, that means that here's the transistor right here, and this is what's brought out. And you could do it as open drain, but then you have to supply a ground right there. So if you go back to our schematic right there, if you look at our schematic right here, and they show the schematic down in here, this is right here. And the schematic is shown. We need to rotate clockwise right here. You know, there's our chip. Here's our ports right there. And actually, you could use them as open drain because they are right. You write a 0 to turn on the LED. So this is how you can tell, by the way, whether or not you write a 1 or a 0 to turn on the LED. Because you look at this here, this is VDD, that's our 3.3 volts right here. We're going through our 750 ohm resistor through our LED into our port right here. Right there. And so we write a 0 to that port that supplies the ground. We write a 1 to that port that turns the LED off. So this is where you tell that. You know, we're nearing the end of the semester. It's time that you need to at least look at some of this documentation and have an idea what it's telling me right there. Because this is our chip right here. We've got on here, we've got 24 pins on our chip. I keep saying 18, there's 24. 2 of them are not connected, so there's 3 are not connected right here. So, but this shows me here's DS1, DS2, and they're tied to the port high end. So if I write a 0 to that port, that tells me that LED is going to be turned off. Okay, getting back to our discussion on the slab right here. That's why we now change that to a 3. You're going to change it as we set up our washing machine. As we add additional outputs, we're going to have to change more. Because I'm looking at using port 0 and going back, do we still have this up here? Yeah. Right here. We're using our 2 push buttons are actually on port 1.7 and 1 there we have our analog on port 1.2. So for right now, we want to try avoiding these pins because they're connected when we actually do our sampling. I'm going to say port 0 is brought out, is it not? Or is it? Actually, no, it's not. We're tying it. We'll have to assign our pins accordingly right there. Right there. So as we, because as we look, port 1.5, 0.5, 2, and those are tied up, being used right here with our programmer. So we can't use those in our code right there. That there. So we have to select which pins we have available to us. We don't have all these pins available to us. That there. Because some of them are used. We can actually, we can use port 1. We can use port 2. We can use these 2 ports right here because as long as we don't push the buttons, we can use those. Or we can actually use those as our inputs. You know, this could be our start button. This could be our full button right there. You know, that there. And then we have another pin for that there. So we have enough pins to work with. We can use these 2 pins. We can also use these 2 pins as 2 of our outputs and add additional LEDs. So we can use these 4 pins right there on the board without wiring externally. That there. So, all right. When we when we actually start the washing machine, we'll have to decide which pins we're going to use right there. Okay, getting back to our timer right there. Don't change. All right, the port initialization, right now, the only change you need to make is make that a 3 in order to get the timer working. Timer 2 initialize. This is already set up to initialize the timer to generate an interrupt 1 time or 10 times every second, right there. So it's set up for a 16-bit auto reload, generates an interval set up a time using the system clock divided by 48 as its time base, right there. So if you look at the system clock is 24.5 megahertz roughly. Actually, it's closer to it's actually about 2 megahertz right there. But if we look at 2 megahertz, and well, scientific, 6, excuse me, clear, 2, where's our EE button right here? I know it's sitting here somewhere in front of me. All right, I hate this calculator. This does have the converter. No, that's the converter. Because if I, all right, let's just put it as 2 million divided by 48. That means that that's how many, that's our frequency right there. It's about 42 kilohertz right there. So if we want to generate, we want to come up with how many times we're going to do that. There, if we look at our code right here, we're sending it, the system clock divided by 12 by 10, we're just simply dividing that by 10. So the only thing that's off is this was written for a different processor, so this is 2.45. Ours should actually be 2 megahertz, the default right there. But it's close enough right there. So regardless, this thing is set up where it starts counting, we pass to it that number, negative, and it's going to count up, and it's going to generate an interrupt 10 times a second is what this is going to do. It generates an interrupt 10 times a second right there. So every time that happens in this original code, this just simply restarts, clears the interrupt flag, and just toggles the LED. Is all this does. We needed to do a lot more. This is where you're going to do all the work for the most part from last week and this week. Now, I didn't bring a board with me. This here starts, the first part here is I said if, so this is that is this code right here that I've just brought out separately. So what I'm saying is somewhere in the beginning of my code, I need to declare another variable, and I'm just going to call it XYZ. So in this code here, we need to add another section right here. Let me copy this right here, and global, and I'm just going to say var. So we're going to declare some global variables, and one of them is going to be an int, and this always changes this to a capital letters because I'm doing it in Word, but int and XYZ is what out there, and I'm going to just set that equal to 10 to start with right there. It doesn't matter. And then I'm going to set another one, int numsec, right there. And I'm going to set that equal to, say, 20 or whatever. You don't have to initialize it. And I'm going to set another one, int nsec, equal to 0, right there. So I'm just declaring some global variables that they're, and I'll talk about those in a second. These are 3 global variables that we're going to be using to control the timer right there. So the first part of this assignment, if we look at it, is review the program here. You spent last week looking at the program. Add a variable, keep track of the number of time. This essentially does this essentially does what we did last week right there. Right there, we change this with X, Y, Z right there, and we subtract 1 from each time. If it's equal to 0, we set it to 10, and we toggle the LED. This changes the frequency in which it operates. Now we need to change this because we know that it's going to get into this function once a second, right? So we need to probably go ahead and we need to change this to now nsec. Just repeat the same thing, nsec minus minus, and again, right there. We're just going to change this there, and if n numsec equals 0, in this particular case, we're going to do two things. First off, we didn't declare another full variable. We're going to set te equal to 1, right? Right there. And that's probably all we do here. Right there. Because we're going to ignore nsec the rest of the time. So we really don't even need to do anything right there. Because we don't want to reset nsec because we want te to remain high until we start it again. So that's all this does right there. Right there. And right there. So we basically just leave that at that right there. Then we need another function, and I'm just going to go ahead and write this function right here. And this function is type void, and it's start timer right there, and it receives numsec, second delay or whatever. I'm going to call it something else. Delay right there. And the only thing this timer does is to set te equal to 0. Equal to 0. Right there. And then we also want to go ahead and hit numsec equal to sec delay. Right there. That's all that does. Right there. Because that's going to, and really this is all you need to do in this function there right at this point right here. What this function does is, all this does is start the timer. Right there. Now, the other thing we want to do here also, I'm going to go ahead and put the brackets back in here so that we see what's going on here, is we're going to go ahead and we're going to say LED2 equals 0 right there. Turn on the LED. And the reason I did that is because here I'm going to LED 2 equals 1, just simply to so that we know whether we're counting or not counting right there. So this starts a timer, and then what we're going to do in main here is we're just going to just continuously in main, what I'm going to do is it's one of these really strange things. Actually, let's just toggle the timer each time here. And the reason I want to toggle the timer is that you can see that it's right there. So equal, and there should be an extra. That doesn't look right. Right there. So we toggle the timer there, and the reason I want to toggle the timer is that so then when we go into main, we're just going to keep. Let's get into main right here. To test this, we want to just simply say spin forever, and maybe if te equal 0, right there, call or start timer. And we'll pass it, say 10 right there. Right there. Just to see that it calls, we're just going to call the function right there is all we're going to do. Right there. We're going to pass it 10. And we're only going to do that when TE is equal to 0. Or TE is equal to, we'll say TE is equal to 1. Or, no, 0. So this will just, as soon as we start the timer, it's going to set TE equal to 1, or excuse me, we did this wrong. Or if TE is equal to 1, we want this to be 1 right there. The reason is, while it's timing, when the time expires, we start the timer, it's going to count down, and then it'll, there, and you will see this flash every 10 seconds. You can change that to a 5, see it changes every, there. So that's basically what you need to do as you look through this assignment here, right here. Modify it to look at NSEC, subtract 1, set TE, that there. In other words, it'll blink, then the last part is start timer. Sets the variable there, and sets global TE equals 0. And the only thing I did I put TE, and you also need to declare TE here. TE and TE equals 0 right there. In other words, right there, we declare another variable right there for our time expired. Right there. So that's basically, and I'm not going to leave this up, so I'll leave it up for a few minutes up there. Actually, you know what I'm going to do? Let me save this and just post this on e-learning so you can download it up there. Save as I'm going to call this Lab 2 with solution. That there. So, and I don't guarantee the solution is perfect here. I don't guarantee that there's not syntax errors, but it kind of gives you an idea where to go. That there. Remember that the goal here is not to write the code for you, but to and if my internet's working properly. And once this is done, I am going to go get some more coffee because I am a caffeine addict. And I recorded that. And it's now on YouTube, the fact that I looked at it. I am a coffee addict. Of course, how many caffeine addicts are there in this room? Now Mountain Dew and Pepsi count. You know, those have got more caffeine in them than you care to think about. What's that other stuff? I don't know. Is Red Bull or You know, someone suggested in my other class that I quit using this and set up a Facebook page. Simply because Facebook is a little bit more reliable out there. Okay, I guess the only thing I can say is, someone got a thumb drive handy? Just bring a thumb drive and we'll just, you can pass it around. That's probably easier than, I'm going to stop recording here before I say something really